Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of the previous lecture tutorials which we have covered these ideas on deducing chemical formulas. So we have done it in terms of going through the valency of the specific elements based on their position in the periodic table. Those are based on group number. For the metals, their valency follows the charges of the ions that they would form, provided that their objective is to fully fill the valence shell. Like group 1 will lose 1 outer shell electrons, group 2 will lose 2 outer shell electrons, group 3 will lose 3 outer shell electrons. They will all form positively charged ions called cations. Their valency follows the charges of the cation. For the nonmetals, we talked briefly about some of them. They will form ions if their partner for bonding is a metal, because metal and nonmetals, they would like to form ionic bonds. I forgot where I put it already, but metal and nonmetals, they like to form ionic bond. But for nonmetals and nonmetals, they like to form covalent bond. So valency could also be an indication of how they would like to combine with each other. So it's the combining power of the elements. Like carbon, the electronic configuration being 2,4, it wants to gain 4 outer shell electrons, or you can think about it wants to share 4 outer shell electrons, because 4 plus another 4 will give you a fully filled outer shell, which is always the objective. Group 5 on the other hand, it would just want to share 3 electrons. Group 6 want to share 2 electrons. Group 7 want to share 1 electrons. The objective again, fully fill out the shell. We talked briefly about these things with Roman numerals, which represent the charges of the cations, and therefore those are the valency of it. I also briefly explained about these 5 polyatomic ions, none of which are given in exams, but unfortunately they are very popular question in the exam for combined science. You must know the name and you must know the ion, and you must know from the ion how to get the name. None of these, including the number of atoms as well as the charges, you can get it wrong. So there are only 5 of them, so you got to remember these 5 for the rest of your combined science courses, because every single ionic compound formula that come afterwards, which I'll explain towards the end of this second video in the tutorial series. I explain how to do the crisscross method, as well as how to manipulate the idea of simplest ratio and not just the whatever number that you get after you do the crisscross. So you gotta have the simplest ratio, such as this, where you need to divide these two number by 2 to give you the simplest ratio of 1 to 1. That's why the formula for magnesium carbonate, this is magnesium ion, positively charged ion. This is carbonate, a polyatomic ion that is negatively charged. Positively charged ion, negatively charged ion, ionic compound, ionic bond, therefore ionic compound properties. They will have high melting and boiling point. They can only conduct electricity when they are liquid or when they are aqueous, but not when they are solid, because the ions will be held in a fixed position and hence not easy or not free to move. Things like aluminium hydroxide, it is 3 hydroxide after you do the crisscross, such as these. All of these were covered in the last tutorial, so you should have a look at it before you move on if you have forgotten anything. In this lesson, in this lecture tutorial, I specifically cover the concept on covalent compounds, as well as the rest of whatever is in the notes. So carbon dioxide, so back in the first lecture tutorial in this series, they say candidates should be able to state the name, state the formula of common elements and also compounds. These are all compounds that have been covered as part of the dot and cross exercises back in covalent bonding. Ammonia is NH3, hydrogen chloride is HCl, methane is CH4, carbon monoxide, mono means 1, oxide refers to the oxygen, whereas this is carbon dioxide, di refers to 2 oxygen. Therefore, this is just CO with 1 oxygen. Sulfur dioxide, there's actually a updated spelling, is SUL FUR as per the element number 16 in your new periodic table. 1 sulfur, 2 oxygen. Water, H2O. Nitrogen dioxide, again 2 times oxygen, so NO2. Okay, when you name covalent compounds, that's basically what it's saying. The first element name remain unchanged, like carbon monoxide, carbon dioxide. The second element ends with IDE to refer to the other elements. A prefix, pre means before, pos means after. pre means before. So before the name, what do you put in? You put things like mono, di, tri, and tetra. Mono means 1, di means 2, tri means 3, tetra means 4. So this is carbon tetrachloride because 1 carbon, 4 chlorine. 1 sulfur, 3 oxygen. 1 carbon, 2 oxygen, 1 carbon, 1 oxygen. However, some covalent compounds have a very special name. Just to recap your memory, nitrogen and hydrogen. Nitrogen is 2,5 electronic configuration, 5 outer shell electrons, 1 outer shell electrons for hydrogen. How many electrons to share? How many to share depends on how many do you need to complete the outer shell. When you got 5, you need 3 more electrons. When you got 1 in the first shell, you just need 1 more electrons. When you do the cross multiply thing, you are trying to figure out how many of each do you need. You just need 1 nitrogen, but you need hydrogen 3 times. That's why the formula is NH3. And from the dot and cross, which again and again and again, I'm telling you that they are very popular exam question. See how the hydrogen form 1 covalent bond with nitrogen. So this is sharing a pair of electrons, 1 from the nitrogen, 1 from the hydrogen. Nitrogen has 5 outer shell electrons. It only uses 1, 2, and 3 for bonding. You still have 2 more in the outer shell because 5 minus 3 that have been used up, you still have 2 more, and these are all part of a covalent bonding topic in the last topic, which you can review again and again until you're very familiar with it, because all of these are common formulas of compounds and also elements as stated earlier, I think back in lesson or lecture tutorial 1. So you can have a look back at those videos if you're unfamiliar, and you can browse through your notes as well. So let's continue. So formula of ionic compound. So they consist of positive ions and negative ions, as I mentioned. This is a table. This is a table of all the possible cations and anions that you're supposed to take note of all these stuff. Okay. So what we have is lithium is Li plus, and then we have also H plus for the hydrogen. So sodium there is sodium, and then potassium ion is just K plus there. NH4 plus is a very special one, NH4 plus, so that is called ammonium. Do not confuse ammonia. Ammonia is this. Ammonia is a molecule. Ammonia has no charge. Ammonium is an ion, so this is called ammonium ion. So when you are confused between words and also spelling, then you get confused between formula. Be very, very careful. Calcium being a group 2, so group 2 ion, it will lose 2 outer shell electrons. So they lost 2 valence electrons. So these things are from group 1, they lose 1 valence electrons. So this thing is just magnesium ion. Zinc is a special one. Zinc is somewhere in the middle of the periodic table. They are in the transition metal or the transition element series, somewhere in the middle of the periodic table. The symbol of zinc is Zn. These are 2 plus ions. So, yeah. So this thing is iron. This is pronounced as iron bracket 2. That's because it's iron 2. And this thing will be lead 2, so you should really put down a Roman numeral 2 next to your name because it represents, remember back in the last lecture tutorial, the number in the Roman numeral in this bracket represent the charges and therefore the valency of that particular atom or that particular element. This is called copper 2. Copper is element number 29 in the periodic table. Aluminium 3 plus because aluminium is 2, 8, and 3. First shell, second shell, and then the third shell. So this is a period 3 elements in the group 3 because 3 valence electron. Now this thing is called iron 3 and not iron 2. Let me just write that a bit clearer. This is iron 3 because this is Fe3 plus. This is iron 2 because this is Fe2 plus. Now onto the N ion. N ion means negatively charged. Cation means positively charged. Most of the time, the cations are mostly metals, but sometimes you get polyatomic, meaning more than 1 atoms. Sometimes you get things with more than 1 possible ions that can be formed. Therefore, you put a square bracket with the number to indicate the charges. Oxide. Oxides come from oxygen. Oxygen oxygen atom is period 2. So period 1 first shell, period 2 second shell, but it's in group 6. So group 6 has got 6 valence electron. 6 valence electron there. So you will need 2 electrons. So again 2 electron. The combining power is 2. The valency is 2. So when you gain 2 electrons, you will have fully filled outer shell. So these are group 6 fully filled valence shell to complete the outer shell configuration. Okay, so this next thing is called sulfide, SULFIDE. So look at the IDE. The IDE means for the elements when they form ions to complete the outer shell. This next one is a very, very tricky one. If you can't read it properly, it's actually S or and then 3 at the bottom. 2 minus is the charge. So let me just write it out very clearly. S or 3, 2 minus is the charge. The name is called sulfide, SULFITE. Make sure you take note of the spelling. SULFITE. Sulfide, sulfite. Okay, so they sound very similar, but they are not the same. There's a change in the spelling here, so it's no longer with the PH. Instead, you should spell it as SULFATE. So this is S of 4, 2 minus. Look how similar they are, but they are totally different ions with 1 extra oxygen. This is S of 4, 2 minus. This is called sulfate. Next one up, you have carbonate. So it's CO3, 2 minus. CO3, 2 minus. Okay. Last but not least, we have this group 7. So these are F minus. Cl minus is called chloride. Do not confuse between the IDE and the INE. All the elements have INE because that's what's given in the periodic table. These are all IDE because these are all ions. These are all group 7 ions. They are all X minus 1 because they want to gain 1 outer shell electrons. 7 plus 1 will give you fully filled outer shell. All the minus 1 ions there, they have the IDE because they are ions, whereas the atom itself or the element itself is end up with INE, such as chlorine, bromine, and iodine. But these are chloride, iodide, and bromide. Hydroxide ion from the last lecture tutorials, OH minus. NO3 minus is what you call nitrate with a ATE. Be very careful, yeah, with a ATE. Make sure you can spell it correctly, nitrate. Now you look at the IDE again. Nitrogen is 2, 5. So you want to gain 3 electrons to get to a fully filled outer shell. Now you have N3 minus, fully filled outer shell. So that is group 5, N3 minus, nitrite with the IDE. Phosphate, PO43 minus. So this is another polyatomic ions. So there's quite a lot of difficult stuff in here, but I assure you, if you know this, no one can ever trick you ever again. All right? Naming ionic compound, we name the metal first and then the non-metal bit. But this is chlorine as an element, as the element itself. But this is in a compound, so it's no longer as the element. Just now as the element is 287, there's the atom, chlorine atom. Now you have Cl minus ion, you have 2, 8, and 8 because you have a fully filled outer shell. That's why it's now called calcium chloride. Metal come before the non-metals in the name. Non-metals end up with the IDE. You see the chloride because this is calcium 2 plus and Cl minus. Lithium iodide, iodide because you have I minus. You also have Li plus. Magnesium oxide, you have magnesium group 2. This is a group 2, therefore it's Mg2 plus. Oxide O2 minus, group 6, so there's O2 minus there. Potassium sulfite, you got to change this spelling a little bit. Like I said earlier, there's a change in the spelling. SULFIDE. SULFIDE is for S2 minus, so it's a group 2. It's a group 6 sulfur, so it's S2 minus. And then potassium, you have K plus because it's a group 1 metal. Metal lose electrons to give you positive charge. Group 1 lose 1 electron to give you plus 1 charge. Group 6 gain 2 electrons to give you 2 minus charge. etc, etc, etc. So all of this is just that when you have iron 2, iron 3, remember iron 2 means Fe2 plus, iron 3 means Fe3 plus. Therefore, different names, different formulas, different compounds. That's what this basically is saying. You gotta put in the names, otherwise iron oxide can be this or can be that. Polyatomic ion, example, OH minus, example, NH4 plus, example, NO3 minus, CO3 2 minus, SO4 2 minus. These are all stated in the syllabus. They expect the candidates to be able to do all of these to get the number of atoms and the charges correct, as well as the name. This is called ammonium ion. This is hydroxide ion. This is nitrate with the ATE. Okay, this is carbonate with the ATE as well. This is sulfate with the ATE in the name of the spelling. Whereas the SO3 2 minus was sulfite. Do not ever get confused. If I were you, I would definitely remember one of these. At least one of them I remember very, very well. Okay, so things like sodium carbonate. So what do I have? I will have Na plus. I will have CO3 2 minus. Potassium sulfate, I will have K plus. I will have SO4 2 minus. Mind you, these are not the correct formula yet, because that is just the formula of the individual ions, and to get the correct formula, that's what we will do as an exercise right now. So I'll just very quickly show you on a blank piece of paper an example, and then we can continue the rest later on. So going back to what we had said sodium carbonate. So sodium carbonate, so we have Na plus, CO3 2 minus. Remember, when you want to do formula of compounds, you look at the charges of the ions and you bring down the number. The number is the valency. The valency is the number on the charge, 1 there. The number on the charge is 2. So, you bring down and cross multiply the number. These are the number on the charge and not the number of atoms. Be very careful. Students always get confused between these 3 and these 2. When you can get this right, the valency is the number on the charge and not on the atoms. When you cross multiply, the 2 on the right goes to the left, the 1 on the left goes to the right. What does this mean? This is number. What does this one mean? There are 2 of these. There are 2 of this thing on the left, so there are Na plus, Na plus. There is one of what? One of this thing. So how are you going to combine them? Na plus, there's 2 of them, and then CO3 2 minus, there's 1 of them. So you can simplify as Na2CO3. This is called sodium carbonate. Na plus, 2 of them, CO3 2 minus, 1 of them. Potassium sulfate. Potassium sulfate, there's actually a change in the name. It should be SULFATE. So let's try potassium sulfate. So when you have potassium sulfate, you can notice from the name, this is a polyatomic ion. We have sulfate, which is SO4 2 minus. Potassium ion from the group 1 metal, K plus. Bring down the charge. The number on the charge is 1. The number on the charge on sulfate is 2. So the number on the charge is 2, the number on the charge is 1. Cross multiply and change the value of the valency. The 1 on the left goes to the right hand side, the 1 on the right goes to the left hand side. What does this number mean? It means how many of these things on the left side, how many of these things on the right side. So what do I have? I have K plus and K plus, 1 of them, 2 of them, 2 of them. How many of SO4 2 minus do I have? I have 1 of them. So altogether, I have 2 K plus and 1 SO4 2 minus. I can simplify it as K2 SO4. When someone pronounces this to you, they pronounce it as K2 SO4. This means potassium sulfate, and that's because there's 2 of these K plus and 1 of these SO4 2 minus. The charges must balance out. As you could see, plus 1 equal to plus 2. This one is minus 2. So plus 2 and minus 2 overall, no charge. Compound have no charge. Ionic compound consists of positive ions and negative ions, but the overall ionic compound has no charge. If you look at these, again, plus 1 is plus 2, minus 2, overall plus 2 plus minus 2 equal to 0. Again, ionic compound has no charge. every single compound, including ionic or covalent compound, has no charge. And that is the purpose of doing this crisscross, is because you want to cancel out the charges, the total positive and the total negative, to give you an ionic compound with no charges at all. Let's just finish off this formula of the following ionic compound. Actually, I think I'll probably leave this for the next lecture tutorials. I think it's probably getting a bit too long now. So yeah, we'll stop it there for the time being. And thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel. And follow me at ptet.chemistry, ptet.chemistry on Instagram, Facebook, and Twitter to get connected and to send in questions and queries and stuff. And yeah, please share the channel widely with all your friends, chat group, relative, seniors, juniors, whoever else you think might benefit from the tutorial videos on the channel. Thank you for watching. I'll see you in the next lecture tutorial, where we will continue more of these examples and hopefully polish up your skills on these techniques.